Just a few days ago, I had the pleasure of joining Jeroen Claus of Phosphor in teaching a workshop to University of Maastricht students about visualizing protein structures using Houdini and KarmaXPU. And this video should serve as a reminder to those students of what we did, as I'm aware that starting out in Houdini can be confusing and a handful. But also, if anyone of you out there, for some reason, thinks about visualizing biomedical data or structural biology data and is just starting out using Houdini, this is your tutorial. A few things to mention here. In Houdini, in the viewport, you navigate by holding down Alt and then using your left, center, and right mouse button to move around the camera. You'll be mostly working here, building networks, and adjusting options of those nodes down here in this window. We will be jumping between this context, which is the OBJ context, whose camera also can display here in the viewport, and the stage context, which is the rendering context. You could think about all these contexts as different programs unified in one operating system. And Houdini being the operating system, OBJ being the program you're using to build geometry, and stage is the program you're using for rendering. The very first thing I want to do is save my file somewhere, my Houdini file. In my case, I have my standard folder here, the Entagma hip folder, and I can call my file really anything I like. Just keep in mind not to use spaces, umlauts, or any special characters in there. Just stick to your standard normal ASCII characters. So let's call this bio_viz_01, maybe. Now the first thing I want to do is visualize a protein structure. And typically those come as PDB files, which luckily Houdini can load by default. I want to make sure that my PDB file is stored in the same directory as my Houdini file, because that will make my life easier. In my case, I already provided such a file, which is the PDB image of an ATP synthase, and I will load this in. So in our OBJ context, we will always work within containers, where we will build certain parts of our geometry. And you could either drop down a general container for that, using the geometry node, or as we want to load in something, we can use the file node, which is just a geometry container. And if we dive in there by double-clicking in there, hitting enter or pressing I, we can see Houdini already dropped down what's called a file node. So keep in mind we are now in the OBJ context and in a container called file1. In here, in the file node, I will select the PDB file I want to load up by going to my hip folder, and in here I should have provided a PDB file, and I think there it is. Let's accept that, and we see nothing. Let's check if something happened by hovering over this node and clicking on the info symbol here, and we can see yes, we have now 18,546 points loaded into Houdini, but we don't see anything. That is because these points are of a rather large scale, which we can also see by clicking on the info symbol. We can see that the size of this geometry we loaded in is about 134 by 214 units. Now, Houdini in principle is unitless. However, the convention is to regard one unit as 1 meter. Yet PDB files have a unit of some nanometer or nanometers as their units. So we're looking at nanometers here when reading this as a PDB file, but as meters in Houdini. Let's not stress about it, as in principle I mentioned Houdini is unitless. I just want to reframe my geometry that I loaded in here, which I can do by pressing either space and F to focus on the geometry, or space and H to home in on it, or space and G. And I can see this is my ATP synthase, just loaded in as a bunch of points. So what I want to do now is isolate some parts of this structure here and visualize them as a ribbon. When again, looking at the info here, I can see under the point attributes that we loaded in a bunch of data stored on each of those points. And in this case, I want to use a name to isolate the points that I'm interested in. Also, I can look at the contents of this data by making sure this node is selected, indicated by this yellow outline, and then going to the geospreadsheet. And here I can see for each point which data is stored on it. For now, what I want to do is create a group first using a group expression. And in here, again, I want to use the name attribute and everything that's named CA and put it in a separate group. Let's make sure this group is a point group, and let's call it, I don't know, backbone or ribbon. Let's call it ribbon. And the expression I'm going to use here is I will look up the name attribute and check if the value of the name attribute is exactly equal to a capital C and a capital A. I can do that with a shorthand. The @ symbol looks up any attribute on a point, then the attribute name, and I want to check if it's exactly equal to CA. And now I can see I only selected a subset of those points. Now, to work further only on these points, I could either delete any points that are not in this ribbon group, or I could use a split node. It really doesn't matter. Let's use a blast node for now and set this blast node to points. And we want to delete not the ribbon, but delete the non-selected part. And that leaves me with only the points that have this name CA. Also, as mentioned, I could use the split, which splits this geometry by using, again, the point group ribbon. And what that does, let's attach a null here, or maybe 2. It splits the geometry into 2 streams. One that contains only this ribbon group, and one stream that contains the rest. So make up your mind what you want to use. Both techniques are valuable and both techniques are legit. I'm going to stick with the blast here and keep working on that. The next thing I want to do is connect these individual pieces of my ribbons through lines. And for that, I'm going to use an add node, which I will set to create polygons based on the group. By default, this node is set up to just connect everything that's in there, which results in those errors here, trying to connect individual parts here. We don't want that. Instead, we want to connect individual pieces based on their attribute value. And the attribute I'm going to use for that is the chain ID, capital I, capital D. And now I'm only connecting parts with the same chain ID together in a polyline, forming our backbones. Now, these lines are a bit jaggedy, so let's smooth them out using what's called a resample node. And I'll attach that below the add. Now, if I switch on the point display, I can see I've got very dense points here. Again, this structure is quite big, and I can dial in the point density by adjusting the individual segment length here. So let's go for maybe a segment length of 1 unit and scroll down, and here set the polygon to be a subdivision curve. And now if I switch off my display points here, I can see I now have round curves here forming my backbones. Now, to be able to set individual colors on these different pieces, and if again I display the info here, I can see we have 22 primitives. That means 22 individual lines. So in order to set the color on each of those pieces, I want to employ a trick. And in the original workshop, I used a piece of Vex here in scripting, but now I want to use the same technique, but just displayed in a graphical manner using the point VOB. So in here, in the point VOB, we can write a small program that is executed on each of those points in parallel, just using a bunch of nodes. So I'll connect this point VOB up here, highlight it, and then dive into this point VOB here by double clicking on it or hitting U or I. By default, I've got these two nodes. One is set up to import a bunch of the most important geometry attributes, and one is set up to output those most important geometry nodes. In our case, I don't want to use any of these pre-made outputs, but I want to use what's called a bind export node to output a new value. And you can name this attribute as you want. In my case, I think I called it in the original tutorial backnum. I can call it ribbonnum, whatever. Let's stick to the original name. Call it backnum for backbone number. What I want to do here is for each point look up on which primitive. Remember, those are these 22 individual lines here, on which primitive a point is a part of. And I can do that by looking up the primnum, storing the primitive number on each point. However, for later, for shading, I want this number, which now varies between 0 and 21, because we have 22 individual pieces and we start counting from 0. I want this number, which now is between 0 and 21, to be in the range of 0 to 1. And I can do that using what's called a fit range node. So in here, as an input, this takes our primitive number, again, ranging in our case from 0 to 21. The source minimum is set up to be 0, that's correct. And the source maximum I want to set up to be our number of primitives minus 1, because again, the primitive numbers start from 0, so the maximum value here should be 21. And I can do that procedurally by moving this a bit to the side, so I have a bit of space, and in the source max, wire in the number of primitives, but from it subtract 1. And we can do so by using a subtract constant node here, which in our case is already set up to subtract 1, so I'll just wire this in here, and now I've got the correct range set up. So these two nodes remap my primitive number into a range between 0 and 1, and I can output that to be stored as my backnum now. Let's go up one level, click on our info symbol here, and I can see I created my backnum here. And let's head into our geometry spreadsheet and check if the numbers check out, so that's going from 0 to 1, and if I scroll through here, I can see irregular increments between 0 and 1. Okay, that's working, perfect. Because what I can do now, using this backnum attribute is, and I'll do that just for demonstration purpose, we will set it up differently in the render engine. Now I can select a color by using a color node, which I'll set up to ram from attribute, and in here check the backnum attribute and maybe set our color range to something different here. And now I can adjust and assign individual colors to these individual pieces. All right, let's delete that because we're going to do that differently when rendering. Now I could feel tempted, in order to give this a bit of thickness, to use a wireframe or polywire node. Let's use a wireframe for now and demonstrate how that looks. Let's just, I don't know, set this to 5 or maybe 4, and feel tempted to use that for rendering and dial in the thickness here. However, the downside of this is this generates additional geometry, which I don't necessarily need. Instead, what I can do is just tell Houdini to take this backbone, the wire here, and give it a thickness in rendering, which I can do by creating a built-in attribute that Houdini will be looking for using an attribute create. And this attribute create I will set up to create an attribute called width. And Houdini in rendering will look for that and automatically generate thick, solid tubes for those backbones here. Let's scroll down and for now set its value to be 4 units in thickness, and you can adjust that later to your liking. It's just here at the first value slot. Now, just for good practice, when I hit the info symbol here again, I can see that the center of my protein here is offset. So it's somewhere in space. Usually it's helpful to have your geometry centered and then move it around. I can center my geometry using a node that's called match size. which I'll just drop down, and which is automatically set up to move any geometry and center it to the world that is 0, 0, 0. So if I click on the info now, my center is, well, extremely close to 0. So after that, if I wanted to translate this geometry, I could either do that in the rendering context, or I could do it here using a transform node, and then maybe rotate this to my liking, and also animate this. So for example, if I wanted this to turn around its y-axis, if I middle mouse on here, I can just adjust those values. So yeah, if I want to have this rotate around its y-axis, there are several ways of doing that. One is using an expression. Typing in $FF takes the current frame number here. So if I hit play now and make sure I check real time, so Houdini tries playing that back in real time. So if I play now, I can see this slowly rotating. If I want to have this rotate a bit faster, I will multiply this by, say, 4, so it rotates 4 times as fast now, and just keeps rotating and rotating. However, if I want a bit more intricate animation, I can also set manual keyframes in here and adjust those values manually. So let's delete this expression by Shift-Control clicking in here, and let's reset this to 0 on the first frame, make sure we're on the first frame, and then Alt-click in here. And if I don't want this Bézier expression displayed here, I can click on the name and show the value. So on our first frame, the value is 0, and I don't know, let's go to frame 72 and set another value on here. Maybe, I don't know, 90 degrees. And also set a keyframe here by Alt-clicking in here. And down on the timeline, you can see with these green bars indicated here that there are keyframes on those areas. Let me just reset this and hit play. And I can now see I've got this rotation that slowly eases into this rotation and slowly eases out of it. And if I want to adjust the way this moves, and for that let's adjust the playback range here, just that we have a looping playback of just these around 72 frames here, and hit play. So if I want to adjust the way this rotation is happening, I can just shift click in here, and what will open up is the animation curve editor. And you can see the values of my rotation along the y-axis being interpolated here. If I want to frame this part of the curve, I will just press space and H over here, and I can now either dial in those individual handles to adjust the way this thing is rotating. So now, for example, we have a really slow beginning and then a really drastic ending. Or if I want to have this interpolation linear, I can just select the curve in here and then click on the linear interpolation here. So now this thing just rotates in a linear fashion. So those are 2 options how to animate values in Houdini, and you can do that on most parameters you see in Houdini. For now, I will delete this animation by Shift-Control clicking in here and just add a null, and that's just for good practice. It doesn't serve any purpose, just except having a descriptive name. In our case, I'll call it out all caps, and that's good practice because Houdini in lists tries to put everything that's called out in all caps on the top. So let's call this out ribbon. And we are done with our protein ribbons here. Let's go up 1 level and call this geometry container, maybe not file, but ribbons. In order to render this, I want to go into our rendering context, which I could either do by setting my viewport here to the stage, and automatically my network view also will switch to stage, indicated by the Solaris name here. Or I could switch between those different pre-configured desktops. One is called build, the other one is called Solaris. It doesn't matter. In our case, let's maybe stick with the build desktop and make sure we're just set to stage here. So in the stage, what I want to do is build up my scene. So my trees here will be very linear. I will just load in geometry, assign materials, create a light, create a camera, and add render settings. So the first thing, loading in geometry, is done using a SOP import. And this import, I can point to any of those nodes I previously created and load up its geometry. So on the sub path, I'll click here, and then you can see my out_ribbon up here, and I'll just hit accept, and I can see now my ribbon has been imported. And also, Solaris automatically tries to visualize the width attribute and display this as a thick outline here. Don't worry, this is just a preview. It'll look a bit better in the final rendering. Next, what I want to do is create a material for this geometry, which can be done using a material library. And I will create a material in there in a second. Let's just finish building our scene tree. And the next thing I want is add an environment light, which I can then use to load in an HDR, one of those 360 spherical panoramic images used for lighting. So to do that, I'll just create an environment light. And after that, I want to create a camera. So let's add a camera here. And then in our viewport, make sure that we are looking through this camera, which by default sits at 0 and might look a bit awkwardly. So in order to adjust this camera with the viewport, make sure that this camera is locked to it, indicated by this red outline here. And then what I should be able to do is select the SOP import, and similarly to our OBJ context, is press space and H to reframe this geometry. Okay, back to our camera. So now I can move this camera around with the viewport, adjust it to my liking, maybe something like this. And if I want to make sure that I don't move the camera accidentally here, I again unlock it from the viewport. Now, the final thing I need is two nodes. One is called Karma Settings. I will set up my render engine here, resolution, file save path, and number of samples I want to use. And then to trigger the rendering and save the images, a USD render up. And this is my very linear, very simple scene tree here. Before we assign the material, let's load up an HDRI in our dome light here. Under the base properties, if I scroll down, I can find the texture slot in here and select an HDRI. And my hint would be to also store the HDR in the same folder where my HIP file lies. One of my favorite HDRs is called Artist Workshop, and sometimes when you download different variants, different versions of one image that have numbers in them, you can see Houdini automatically tries to interpret them as a sequence. In this case, I do not want to load a sequence, so I have to uncheck Show Sequences as one entry, and now if I scroll down here, I can see those two variants of the Artist Workshop. A 4K resolution is more than enough here, so I'll hit Accept here. And after a while I can see this backdrop has loaded now. In order to set up my materials, I want to set this viewport now to display the final render quality using the final render engine called Karma, which I can do clicking up here and setting my viewport from Houdini GL to Karma. This will take a few seconds, and after a few seconds I can see this is what my protein structure looks like rendered in Karma. So let me just here to get rid of that display and maybe also uncheck the display of that background grid. And also just for later, just also uncheck the display of the icon of my dome light and just display the dome light as is. So now this is looking pretty gray and pretty boring. So let's first create a material and then assign it to this geometry. So in my material library, I'll dive in there. The node I will have to use to shade this correctly in KarmaXPU, which is the engine that we are going to be using, is a Karma Material X subnet is here. First thing I'll do is rename it to ribbon and then dive in here and create the material. All of these nodes I don't need, so let's delete them. Instead, I want to work using a standard surface here, which will drive how the surface of this geometry looks. The output of this surface goes into the surface output here like this, and just to make sure that I assign this correctly, I usually tend to set a very garish base color on this standard surface, and then on our stage context here in the material library, I want to assign this by first selecting the material blob. In our case, it hides on the stage, material lib, and then ribbon, and then check assign to geometry. And in here, to assign this geometry to everything that's coming in through this slot here, I'm going to select all components. That's kind of the catch-all. So now I can see this very garish pink material has been assigned. Now what I want to do is use this back number to assign individual colors to individual pieces of this ribbon structure here, which I can do by going into the material library and then into our ribbon material, and in here loading in the backnum attribute. You know, the attribute from 0 between 1 that we created previously, by using what's called a USD primbar reader. And I'm as unhappy as you are about this name of this node. So what I want to load up is a single float value, that's correct, and the variable name here is called backnum. I think that's what we called it. Let's see if that's correct by just piping this output directly into the base color. Yes, as this backnum value ranges between 0 and 1, I can see different colors of gray. However, if I want to remap these gray colors into a color range that I can dial in, I'm going to use the Karma Material X color ramp here, which just goes in between here. And then I can use this ramp here to dial in the colors or use any of those presets here, for example, the plasma. And now the values from 0 at this end to 1 at this end get remapped into these colors, and I can adjust those to my liking by just clicking on one of those nodes here and then clicking in here and dialing in the colors. All right, that's my basic shader. Let's just maybe organize our node a bit. A few more things. Let's zoom in here a bit. The glossiness of my material can be driven, or the actual reflection of the material can be driven by the specular tab. So I can either dial back the specular to be non-existent or to be half shining through or be full there. But also I can adjust the roughness here to be either more mirror-like or more blurred out, more rough. And then the behavior of this is highly dependent on the index of refraction, which is just a physical property of your material. The 1.5 is somewhere in the ballpark range of plexiglass, glass, or plastic. Water usually has an index of refraction in the range of 1.3 to 1.32, I think, so a bit more subtle reflections. And diamond or synthetic materials can have indices of refraction of 2, 2.2, something like this, to a bit more pronounced refraction here. I'll leave this at 1.5, the default value in here, and maybe increase the roughness a bit, like so. I can live with that. Also, if I want this to be like metal or appear like metal, under the base slot I can increase the metalness. If I dial this all the way up, I can see I now got my rough metal. Again, the specular roughness drives how shiny or how rough this metal is. Again, I don't want metals here, so I'll dial that back. And just if you want to render glass, which I highly advise from not doing because it's expensive, you can increase the transmission here, which will turn this into glass. And now if you want the colors back, you can adjust your transmission colors either by setting them directly or similarly to what we've done with our base color, just pipe the ramp into our transmission colors here, and now we have this. It can get dark with those really, really strong colors here, so what you'd have to do is adjust those colors and make them a bit more subtle, a bit more translucent, like this, and maybe also like this, so we get a bit more visibility through our material. You can see this already renders really slow, so again, I advise you to stay away from it. All right, let's reset this to the standard plasma ramp, and let's just cut this transmission color here, and also dial back the transmission. That's just a really quick overview of it. One final thing I want to mention, if you want this material to emit light, you can go into the emission tab and increase the emission here. Again, a really bright light might need an emission of 5 or something, and then again you can dial in the emission color, usually something on the red-orange spectrum, and this will now illuminate other parts of the geometry if you want. And you can also, similarly to the base and the transmission color, take our ramp and wire that into our emission color, so now the emission has been driven by this ramp that you set up. In this case, however, I do not want that, so I'll press down Y until this scissors symbol appears, and then just draw a red line to disconnect, and dial back the emission here to 0. And maybe under specular, let's set the specular roughness to 0.4, like so. Okay, I can live with that. Let's look through our render camera again, the camera 1 here. So that's the appearance of my ribbon structure now. Let's go back to our stage and set this up for final rendering. If I want to animate in here, what I can do after I imported my geometry and assign the materials here, I can use a transform, similarly to what I've done in my OBJ context here. And first what I want to do is select not this preset primitives, but again, all components, so anything that's wired in here will be transformed, and then in this case I will just script a rotation again by using the $FF for my current frame and maybe multiplying this by 5. So I get this rotation. Let's just here and hit play, and that is not really real time, but if I skip through here you can see this thing is rotating as I'd expect it to. So if I want to render out this animation, the first thing I want to do is set up my render engine, which is done in the Karma render setting. In here, first, I want to set where my image sequence will be stored to. And typically, I advise you to modify this expression in this way. So now we will create a subfolder. Wherever this scene file is stored, we will create a subfolder called render, and then in there another subfolder with the same name as our project file, and then in there store a sequence of images as 0001, 0002, etc., etc. The file format is set up to be an EXR, which is fine, which can be read in Resolve. However, for easier preview, if you haven't got a proper image viewer installed, I want to set this to PNG, and then I want to set my render engine to the XPU engine, which is a good bit faster than the CPU engine here. And after a bit of calculating, Houdini starts rendering here using not only my CPU, but also my built-in GPU or GPUs. Also, my output resolution typically would be 1920 by 1080, so full HD. And now let's talk a bit about these other settings down here. First, the path trace samples. This is my main slider of dialing in the image quality. A lower sample count, maybe let's go for the extreme, will result in a very grainy image. However, it will render really quickly. A higher sample count will result in a very clean image. However, this is going to take a while to render. So my advice is to make up your mind how susceptible your eye is to noise and make a conscious decision. Also, there is another neat trick here. Let's set this to a rather low sample count of 8, and you can see quite a bit of noise down here. However, under the image output and filters, you can see there's a denoiser tab. And if we set this to the Intel OIDN and re-render it, you can see that after rendering, it clears up. Sometimes this denoiser can result in artifacts. However, in most cases, it really works nicely and allows you to use a rather low sample number to generate your render. So keep that in mind. And if you're getting too drastic artifacts, either deactivate the denoiser or increase your path trace samples, or maybe both. One more thing I want to talk about under the rendering tab, in the limits here, you can see that there are limits for diffuse bounces, reflection bounces, refraction bounces. These limits indicate how many hits a ray that is sent out from the camera to sense the scene and create the render engine and create the rendered output, how many intersections each of those rays can have. When you're rendering glass and have a lot of glass geometry behind each other, you might have to increase the refraction and reflection limit in order not to get blackout effect. And my diffuse limit dictates how many bounces my light can perform. So typically when light hits a surface, the light bounces and illuminates with nearby surfaces. In this case, to speed up the rendering process, Karma only calculates one of those bounces, and as soon as we hit the second surface with the diffuse light, we don't calculate any more diffuse lighting there. I typically like to increase it as well to maybe 4 units, and we should be able to, in those dark areas, get a bit of a brighter rendering now, just a tiny bit. And maybe, just maybe, increase my path trace samples to 16 and not 8, and yeah, in conjunction with the denoiser, that is really looking nicely. Let's save this, and the final thing I want to do to trigger the rendering is go into the USD render up here and switch my frame range from a current frame to a specific frame range, and by default this is set up to render the whole of your timeline, and if you don't want that and manually adjust that, let's just shift control click in here in those both numbers, and let's only render frame 1 to frame 72. Alright, let's save this and hit render to disk, and finally you will be greeted with this progress bar, which is progressing quite slowly, so typically you want to start rendering before getting a coffee or maybe overnight. And as soon as a few frames have been rendered, we can open up the folder into which we are storing these frames here, and we can see these individual images. So let's double click on one, and in my case I've got DJB view installed, which automatically opens up the sequence, and we can see those few images that have been rendered. So let's click stop and inspect them a bit, and yeah, that is looking nicely. And also you can see that the backdrop has been cut out and is transparent. So in your editing software, you can add any background and any background color you like. And that is your standard ribbon structure visualization done here in Houdini and Karma. And if you like what we're doing, want to support us, or gain access to more in-depth tutorials and courses, consider becoming a patron of ours, as it is through Patreon that we are able to run Intagma the way we are doing. And if you're already supporting us, thanks so much, with a very special thank you going out to Important Looking Pirates, Jellyfish Pictures, The Mill, Method Studios, Pixonic, Random42, Rodeo Effects, Side Effects, Lusion, Style Frame, and Rafik Anadol Studio. Thanks so much. And as always, until next time, it is cheers and goodbye.